Hello and welcome. In this final video, I'll illustrate some practical examples related to MBS and will also show you a potential final exam question. So, monthly prepayment rate or SMM. Let's begin with this. It's a very important concept. The ratio of the prepayment in a month and the amount available to prepay that month is called the single monthly mortality rate. Don't worry about this term mortality. It's scary, but it's just from actuary language or jargon used by actuaries, right? So it's called SMM. Basically, it means monthly prepayment rate. Now, SMM for a period T is equal to prepayment in month T, like whatever that amount has been repaid in a given month, divided by beginning, in brackets, beginning mortgage balance for month T minus scheduled principal payment in month T. In other words, the outstanding balance for that month. How much was outstanding and how much has been repaid. You take the difference and you divide the prepayment in month T by that amount, last amount. That's called SMMT, or prepayment rate for that month. Now let's illustrate the calculation here. So beginning mortgage balance is in month 33 is 358,326,766. The scheduled principal payment in the same month is 297,825. Now prepayment is 1,841,347. We just take this 1,841,347 and divide it by the difference, right? How much has been repaid as usual. And you get 0.51%. So on a monthly basis, it's a very small percentage, right? But then if you actually had this kind of prepayment each and every month on a very long-term mortgage, it would amount to a lot. And I'll illustrate it in Excel shortly. Now, there is also something called annual prepayment rate. You take the monthly and annualize it. So there's a formula here. It's very easy. So you take the SMM, subtract from 1, and raise it to 12th power. You know why, right? Because there are 12 months in a year. And then you annualized it. So it's called conditional prepayment rate, or CPR. So let's say you've got this SMM of 0.51% that you calculated earlier. The CPR will be around 6%. Okay? A CPR of 6% means that ignoring scheduled principal payments, in addition to those, approximately 6% of the outstanding mortgage balance at the beginning of the year will be prepaid by the end of the year. And that happens each and every year. Imagine if you had a 30-year mortgage. It would be a lot, right? Given a CPR, the corresponding SMM can be computed by solving equation for the SMM. It's the reverse of the function. So SMM is equal to 1 minus this, 1 minus CPR in brackets raised to 1/12th power, right? It's the opposite. So you can actually go back and forth between SMM and CPR using these two formulas. Now let me show you a benchmark, prepayment benchmark that's used in the US. It's called PSA, Public Securities Association benchmark. And what they do is they looked at the behavior of the mortgage borrowers, and they noticed that after a while this prepayment rate slows down and it levels off, and there is a period. It's like 30 months here. So this is the behavior typical in the US. So what happens is that the prepayment rises. In other words, they prepay faster during the first 30 months, and after 30 months there's a limit. It's like a ceiling, and that ceiling is actually benchmarked using PSA 100. 100 means the benchmark of 6%. So the prepayment rate doesn't exceed 6% after 30th month, all the way to the last. So if there were like 360 months or 30 years, it would stay 6% from month 30 to all the way to 360. What if the PSA 100 can be scaled to higher level? Then you could just multiply this 6% to, let's say, whatever that multiple is, and then that would be the new limit. For example, if the PSA is 200 PSA, then it would be 12%, 6 times 2. I'll show you using a video. So what about 150 PSA? Well, it's 1.5 times 100 PSA, right? It's 1.5 times the 100. So 1.5 times 6% is 9%, and so on and so forth. So 300 PSA would be 18%. So let's apply the PSA to calculate this. Let's say the SMM for month 5, month 20, and month 31 through 360, assuming 100 PSA are given. So CPR is 6% times month 5, right? It's going to be 1%. For month 5, it's going to be 1%. SMM is going to be calculated accordingly using the formula I showed you earlier. For month 20, CPR would be 6% times 20 divided by 30. So it's going to be 4%. And for month 31 to 360, it would stay 6% because if you remember, there's a limit here, right? There's a ceiling. So basically, if T, the number of periods, is less than 30, any number of months between 0 and 30, you can actually calculate using the formula. And if it's after 30, it's gonna, you just put the limit, whatever that limit you had. So let's look at some Excel here. Now let's look at some example using Excel. So let's say CPR is 0.2%, SMM is calculated accordingly using the formula. And let's look at some PSA profiles. So if T is less than 30, so this is PSA 100. The PSA 100 has a limit of 6% after 30th period, right? So then you've got these little steps that take you all the way. So PSA 50 to the half, so the cash flows would look like this. Okay, so here this cash flow is based on this, right? The PSA. So PSA 50 is this cash flow, PSA 100, PSA 165, and all the way to PSA 700. So I'll make this Excel sheet, spreadsheet available for you so you can play with this. So in the end, what actually is interesting to see is when you have high levels of PSA or high multiples of PSA, the average life of this pass-through or the mortgage bond will be much less. For example, this is based on a 357-month mortgage security. In other words, almost like 30 years. If you have as low a PCA as 50, which is like 3% limit, only 3% a year, the average life of this 30-year mortgage bond is only 15 years. In other words, the principal amount is repaid in just 15 years. And when you actually increase the multiple to 700, this 30-year mortgage becomes like the average life of this becomes less than 3 years, like 1/10, less than 1/10 of the original maturity. So it's going to be prepaid much earlier. So the higher the amount of prepayment, the higher the prepayment risk. So there's another example here, and I've illustrated the average life here. Now let me illustrate another concept that's important. So let's say you've got a mortgage loan, which is $150,000. You've got a mortgage rate of 7.25%. And you've got monthly payment calculated based on this. It's an annuity. And the term is 30 years. So it's all the way to month 360. Okay? And here this graph illustrates the amounts that are basically here. The blue one shows you the interest repayment, how much interest is paid, and this shows you how much principal amount is repaid. Okay, so notice that they go in the opposite direction. Interest over time drops while the principal repayment increases, and this is called fixed amortization schedule. It's very typical for mortgages. So I want to basically introduce a concept called servicing fee, because each of these mortgages have a servicing spread included. When you include the servicing spread into this bond, mortgage rate is 7.25 if you remember. Notice that I need to include the fee inside the structure. So let's say the servicing fee is 0.5% or 0.5%. So how do you add it? Well, I just take the servicing fee multiplied by the beginning balance for the period, and I keep doing it for each period. Notice that servicing fee is dropping over time, but then it adds up to some amount, right? So overall, then return to the investor will be 7.25% minus the servicing fee. Okay, in other words, they receive less than basically when there would be no servicing fee, and the return to the investor is whatever is left over. And here is a potential final exam question. Consider a $100,000 10-year 9% mortgage loan with monthly equal payments. Do the following calculations using Excel spreadsheet. What are the scheduled monthly payments? After 1 month and 3 months, what is the CPR and SMM, assuming PSA 100? What is the scheduled principal payment? If it pays down at PSA 200, what is the prepayment amount? What is the remaining principal balance? Enjoy.